Yeah. So is my screen visible?
Yes, sir.
Okay. Okay, so essentially we have two major chunks remaining. One is certain text processing utilities, and the final chunk is about shell programming. So this will introduce to you a set of, I would say, tools, no longer something like programming in C and similar things. So anyway, without further introduction, let us go directly to the topic. So in this class and next class, and if needed, the next to next class also, we will discuss some text processing utilities, and in particular, we have this roadmap to follow. So Unix provides a lot of utilities to process text files, and also, whatever you can supply from stdin, that is also fine. And here are a few simple comments. You can just say man sort to see what sort does. It essentially sorts a file line by line. There are many options anyway. Likewise, unique removes duplicate lines. Duplicate lines occurring consecutively. So it makes sense when the file is sorted. Otherwise, usually it's not very meaningful. And I think we have already talked about this WC word count. If you supply to it set of files, one or more of them, it will tell you how many characters are there, how many words are there, how many lines are there, along with a summary total. Okay. And there are many such simple things which you should, I would say, look at the man pages to know more about. So in what follows in this section, we will focus on some of the more sophisticated text processing tools. Okay. So not simple-minded things like sorting or removing duplicating line or counting words, characters, and that kind of stuff, but something more serious than that. Okay. To start with, I will talk about regular expressions, which you already are aware of, right, in your flat codes. And so we'll start with what is meant by regular expression, how to write regular expressions in Unix, and a utility that handles this kind of regular expressions. There are actually many utilities that handle regular expressions, including the shell itself. But grep is one such thing. So I will tell you how to use this grep to see all these pattern matching examples. Then I will talk about something called the stream editor, SED, and that selects lines in a file based upon line numbers or patterns. Patterns mean these regular expressions, and can do a set up some simple or primitive tasks on the selected lines. Okay. Finally, we'll also talk about something called AWK, awk, the GNU version of it actually. We'll talk about Gawk. In fact, it is a full-fledged programming language, but it's basically motivated in handling text databases. Okay, so we'll come to that, how these text databases should be written, what are the things awk can do on this database entries, and all that stuff. Okay, so this is the basic roadmap. So I will today introduce to you something about these patterns or regular expressions that many things, many utilities can handle. And to start with, these regular expressions are essentially the same as those introduced in your flat codes. The only thing is that the way we have written these regular expressions in your flat codes will be a little bit different. The syntax is different, how to write these regular expressions. Okay, the constructs or the syntax is slightly different. And these regular expressions are used by a lot of utilities, including the page by page viewer of text file called less, and all these things, grep, sed, awk, shells, and many text editors, including VI and Emacs, they also use the same set of regular expressions in the same syntax. Okay. So for the moment, I will just use this less program to demonstrate how this pattern matching works. Okay, because it gives a good visual demonstration of the regular expressions. grep also gives you the lines that match anyway, so we will see later. I think if possible, we will do a little bit of grep today, otherwise we'll go to refer it to the next class. And run this less with the -n option to show the line numbers. Okay. And what you can do when this less is active, you can simply type this / and then something will happen. We will go to the last line. There you can type a regular expression and then hit return. You will see all the matches. Okay, and these are highlighted. Okay, and searches are made in each line. And so whenever I say whether this regular expression can be found, this means the searches are made line by line. Line number 1, is there a match or one or more matches? If so, all the matches will be highlighted. Then we will go to the next line. Are there any more matches here? All the matches will be highlighted, and if there is no match, that line will remain unhighlighted as usual. And remember that in Unix style regular expressions, the new line character is not allowed to be a part of any regular expression. Okay. Although the new line character is a character in its own right, but you cannot introduce new lines in a match. Okay, so let us see how we can use this less utility to see matches. Okay, so for example, I run. So this is a sample file, some abstract for some talk that I gave somewhere. I do not remember where. And if you run less -N, that file name.txt, whatever it is, it gives you a view like this. The line numbers are given 1, 2, 3, 4, 5, 6, 7, 8, and so on. And here is a colon. Now, when you are viewing this, if you hit the / something like this will happen. Okay. So colon will be replaced by this /, and there you can type the pattern that you want to search. For example, I may search. I am here searching for just plain, I would say, literal string RITHM. So I simply type RITHM here and hit a return. Then what will happen? It will mark the matches like this. Okay, RITHM appears here. Logarithm also has RITHM. These are all the matches that were found by less. Okay. Okay, so is the interface clear? These pictures are just for letting you, visualize the different constructs. Of course, a literal string like RITHM is definitely a regular expression, but we can not only search for these literal strings, but a lot of other things we can do. Like you have seen A + B whole star, sigma star, that kind of stuff. Okay, so how do I enter these regular expressions. Okay. So this is what we will talk about next. And I will always demonstrate all the matches found by less highlighted this way. Okay, this is just for visual demonstration. Okay, so let us understand the constructs. Okay, apart from, I would say, literal strings like RITHM. Okay, so first thing, it's something like your sigma matching a single character, and it can be anything, of course, not new line. New line is not allowed in any regular expression. So, what did we use in our flat course? I think it is hash, right?
Yes, sir.
Yes.
Hash we have used. Instead of hash here, we will use period, dot. Okay, to match any single character. Okay. And for example, if I say the pattern A dot G, the pattern should start with A. This will be followed by any character, and this will be followed by G. Okay. So for example, here you see ALG matches here, ARG matches here, ARG matches here, ALG, ANG, and more importantly, you look at this example where there is a space. So space is a character in its own right. Okay. So these are all the matches of A dot G. So dot means any single character that can appear in a line. Okay. Single character. Okay. So that is like hash in our flat course. Then how do I match a set of characters? I see this thing opens here. Good. Anyway, matching a set of characters. So it is something like A plus B plus C. Then we will see how to make whole star. Star is the same thing as in your flat course. But here I can I would say specify a set of characters. Dot means anything, right? But if I want to match only some sets, some limited number of characters, then I will use this square brackets and I will write the characters that I want to match within this. Okay, so let us see some examples. Okay. For example, if I write this way, this means either capital T or small t, uppercase T or lowercase t. Okay. And we also allow something called ranges, but anyway, let's say if I say A, E, I, O, U all in uppercase, then this thing matches a single character from this set. Okay. It matches a single capital T or a single small t. And this matches a single uppercase vowel. Okay. I can also use this range thing, A to Z. Okay, this matches any lowercase letter. But this is only a single match, not multiple matches. Okay. So A to Z, so this minus is a special thing. Okay. This gives a range instead of specifying A, B, C, D, E, F, I, okay, everything. I can simply specify this range A to Z. Okay, this matches any lowercase letter. And I can separate these ranges one after another. So the matches just one character, which may be either a lowercase alphabetic letter. Oh, I see there is a mistake. This should be capital Z. Okay, I will correct this. A to capital Z or any digit. So it matches a single alphanumeric character. Okay, so now let us see what this more complicated pattern means. Okay, so I will start the pattern with an uppercase letter. This should be followed by a lowercase letter or space. Okay, so you can see the space here, right? Although it is invisible, you can see that something is sitting there, and that is the space. This should again be followed by another lowercase letter or space. This is followed by any character. Dot is any character. Okay. And you can see that these patterns can be identified. Should start with capital letter. So A is fine. B is fine, lowercase or space. Small s is fine, lowercase or space. Followed by anything, T can be anything. Okay, and let us see some more thing like this, capital letter followed by lowercase or space followed by anything. Whereas if I want to start the search from capital M here there is no match because this closing parenthesis is not part of this. Okay. And there may be other examples where you see that there are no matches. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Yes, okay. Sir. This is fairly straightforward. You already know all these things. You are just learning the new constructs. Okay. And you can not only specify the groups, you can also negate them. Okay. So negation of a set of characters. So immediately after this opening square bracket, if you say is caret character, okay, then it means match anything other than what follows. Okay. For example, if I say not followed by a space, so it matches any non-space character, anything which is not a space. Okay. And this, if I say something like this, not of A, E, I, O, U, capital A, E, I, O, U, this matches any character other than the vowels. Okay. And this is another example that uses not only this not thing, also the ranges. This matches a single character which is not alphabetic. Okay. And here is a more complicated pattern. What does it say? This must start with an anything other than an uppercase vowel. Okay. This should be followed by a non-alphabetic character, not also space. Don't ignore this space. Okay. This should be followed by 1, 2, 3, 4, 5 characters, anything. This should be followed by, this is not negated. This should be followed by A to D, which means ABCD, or R or T. Okay. So let us see some such match. So R is not, for example, an uppercase vowel. So a match may start here. This is followed by any character other than alphabetic character or space. So minus qualifies for that. Here comma qualifies for that. This will be followed by any 5 letters. For example, here I have F, A, C, T, O. This should be followed by either ABCD or R or T. Okay, so you see T here, R here, R here, A here. Okay. Okay, so it should be straightforward, right?
Yes.
Okay. So, in addition to literal things, literal strings, you can specify things like a group or the negation of a group, any character, things like that. Okay. So far we are talking only about matching single characters, but what about something like sigma star? So that is the same thing, the clean star or the asterisk, whatever you call. So use star. Okay, exactly as you use in your formal language course. Okay. For example, dot star matches any string, and this is same as sigma star. And if you say dot followed by dot star matches any non-empty string, and that is same as sigma plus. Makes sense, right? This is basically sigma star. This is basically sigma plus. The only difference is that you specify the things a little bit different way, because it's not so easy to type sigma in your keyboard. Nowadays, it's still possible, but when Unix was designed, there was no concept of this 16-bit UTF encoding and all that stuff. Okay, Unicode characters. So all these constructs are based upon the standard ASCII keyboard, whatever you can type. And A to Z star, this matches any sequence of lowercase letters. Okay. And if I can also negate this, so matches any sequence of non-alphabetic characters. A to Z, capital A to Z is alphabetic, not this is followed by any number of such things. Okay. And here, result of searching this. So what does it say? Start with a capital letter, followed by any alphabetic character or space, 0 or more of them, and end your match at something which is not a space. Is it clear? Start with a capital letter. This is followed by any number including 0 of alphabetic letters or space. This will be followed by a non-space character. And if I run this on that file, I will get something like this. Okay, so this point I will come little later. For example, if I look at this capital T followed by this, space is allowed, and then minus. Okay. So you may also ask the question, if I look at this line number 7, say capital letter followed by lowercase or alphabetic letters or spaces ending in some something which is not a space, F is not a space. Okay. So you may then say that this match also ends at Y. Yes or no?
Yes, sir.
This match also ends at O. Anything which is not a space. Okay. But then why is this match shown? So that is what is essentially told in this line. There are two things you should know. When you specify a match, there may be multiple, I would say, occurrences, one sitting inside others. Then this matching has two, I would say, heuristic ideas. First of all, it should start as early as possible. So it's a kind of leftmost match, and starting from the leftmost match position, as long as possible, it will keep on matching. Okay. So this pattern also matches, for example, T, H. Capital T is here, H is here. Okay, not H is here. I can take just 0 occurrences of this. And this is followed by H, which is not space. So TH also matches this. Okay. It's a leftmost match also. But the philosophy of this Unix regular expressions is that the match should start as early as possible, that is leftmost, and it should be as wide as possible. Okay, never.
Sir,
Yeah, tell.
so I had a doubt like in the third point, if we write it without the asterisk sign, it means that we are selecting just one character out of the
Exactly.
lowercase.
Exactly. Exactly.
But
Yeah.
shouldn't it be like if we apply a star, shouldn't it be like the single character that we choose should that we just repeat it? Like
No,
if
no,
we
no.
are
No, 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 no. It's not A.
yes,
Anything in the range. Okay. You think about your, I mean, think about your formal language thing. If I say sigma star, and if sigma is A comma B, the first character can be A, the second character can be B, the third can be B, the fourth can be again A. It's not A power something,
so
right?
the alphabet is the entire character set here.
Yeah, here the alphabet is A to Z. I am
Okay.
restricting it to only A to Z. Think of this as sigma, and whatever sigma star means, here also it means exactly the same.
Okay, sir.
Okay.
Yes.
Oh,
So I have a
oh,
So
question.
what about new line characters?
what about?
New line characters.
New line characters are never part of any regular expression. New line character ends here, and these patterns are searched line by line. New line character is never appearing in regular expressions or also in the strings where the search is made. Okay, so you cannot search for new line characters using these constructs.
So let's say I have a regular expression, which let's take the seventh line, and let's say it starts with T, like capital T or small t, and goes for let's say 30 characters or something. It's long basically.
Okay,
And let's say one match is starting from the first capital T and it ends like somewhere after the next after that.
whatever.
Then this the will also have a pattern of itself and that will go.
No,
So
so you means
when
if you have two overlapping things,
yes sir, yes sir.
okay, then use this leftmost.
Okay, so like then what will
This
happen, like I will not be able to see what's highlighted, right?
you will not be able to see because that is consumed by another pattern, another
Yes,
occurrence of the same pattern. Yes, that's true.
yes.
That's true.
And let's say like if that I give a pattern which is like of length 30, I mean that is in inbuilt and of the regular pattern, and two of matches are overlapping, then the match I see will not be of length 30, right? Because this has some overlap.
No,
So
no,
then again it will be an
no, no,
issue.
no, no, no. That's what you mentioned. Suppose some pattern matches these algorithms highlight the roles. Okay, some pattern matches this. And some pattern matches, let's say, the same pattern matches the roles played by the apparent, let's say. Okay. Then, but I would say, starting from this two, let's say, roles, okay, this will be your first match.
Yes, sir.
Second match may be the roles played by the apparent or whatever. Okay. Now it will show the leftmost match. So this leftmost match comes here. It will show this up to roles. Okay. And when it starts searching for the next match, it will start after this, not before this.
Okay, so the roles played by the apparent will not be even be shown.
Will not be shown. Yes, that's true.
Okay, sir. Okay, sir. Got it.
Okay.
Thank you, sir.
It will not be shown. But if we have something like to disjoint matches, this will be shown like this, because this starts strictly after this. Okay.
So then one issue may occur, like one character, one regular match ends and the next one starts
Before it.
immediately after that.
Immediately after
There is
that.
no space or anything
Then
in
that's,
between.
I would say that then your visualization is not perfect. It may be
Yes,
confusing.
sir.
Yes,
Yes,
that's
sir.
true. That's true. For example, if this started immediately after this, then it would look like a single match. Okay.
Yes.
Okay. And if, like your KMP algorithm, if you want to restart the search again from the second character, then you have to do something about the line. Okay, somehow you have to specify that I am starting my search again from the second character, again to the third character, fourth character, fifth character, but that will require you to handle the strings and the languages, or I would say things that I have talked about, like awk. They provide, or even bash shells, they provide you constructs to play with strings that way. And then you can say, I have got a search here. Again, I want to make a search, new search, this time not from the beginning, but from the second character. You can tell that, but for that matter, you have to handle the strings. There is no problem with regular expressions. And less is just a visualization. Okay, it does not do anything serious about these patterns. Okay, I'm showing you these things just in order that you may visualize how these patterns work. And what you do with these patterns, that we will see later. Happy?
Yes, sir.
Okay. Yeah, in fact, when we do shell programming, you will see such an example where you yourself identify all the patterns in some sense, and you yourself provide a visualization like this. Okay. Okay, we'll see. Let us proceed slowly. And what else remains here? Okay, so this is another construct which is exactly not present in your flat, I would say, kind of stuff. Okay, so if you want to start the matching from the very beginning of the line, so we use once again this caret symbol. Okay, so it not only means negate a set of characters, it also means, okay, start your search from the very beginning of your line. Okay, whatever string where you are searching. Okay, but if it appears within or after a opening square bracket, it means negate. Otherwise, it stands for start from the beginning. Okay. So for example, okay, and this is the corresponding thing, dollar. Okay. So if you want the match to finish at the end of the string where you are searching, you use this dollar as the last character. Okay. So for example, let us see if I say something like this, the pattern essentially means start from the beginning of the string. There should be, at the beginning of the string, you should have a uppercase letter and uppercase letter, and that should be followed by any number of lowercase letters. Okay. Essentially, it means if the file is a complete text file, matches the first word of a line if the line starts with a capital letter. Okay. But if this caret character is given after this, okay, then it will essentially say match a single character which is not a capital letter. Okay. And maybe there is an example of dollar, yes. And if I say any number of lowercase letters followed by dollar, it matches the last word of a line if the line ends with a lowercase letter. And if the last word consists of lowercase letters only. Okay. So let us look at a more, I would say, complicated pattern. This says you must start from the beginning of line. This says the search must succeed when it produces it, when it goes to the end of the line. And inside the line, what will you allow? Any uppercase letter, any lowercase letter, comma, or space. Okay. And these are the results. So this is a match occurring across the entire line. Okay. Line number 1, no problem. Starts with capital letter. Okay. And whatever appears in between, it is fine. Line number 3 is not there because line number 3 is also there because starts with a capital letter and the entire line consists of only these characters. Line 4 is not matched because it does not start with a capital letter. Although if you did not mention this, okay, then the search could have succeeded. Search would have succeeded if you start from here. Okay, but by forcing this correct character at the beginning, you are saying that search must start from the very beginning of the line, not somewhere here. Okay. And line number 11 is also not there, although it starts with a capital letter, but it has certain things like this minus, colon. These things are not allowed in this star. Okay. Any problem?
So any expression starting with this great sign and ending with dollar will include a single complete line if it matches.
Yes.
That's all.
Yeah, so you are instructing the pattern matcher that you must start from the beginning of the line and must end at the end of the line. And inside this pattern, if the line qualifies for being selected, it will show. Otherwise, not. Okay, line number 11 does not qualify because of this minus, hyphen, or this colon. There may be other things also. Maybe line number 16 does not qualify because it contains characters other than this parenthesis, for example. Line number 19 also does not qualify because of this comma, because of this also, parenthesis. Okay.
So,
Yeah, tell.
so the star character means 0 or more occurrences.
0 or more, yes.
So can we say line 10 matches with the pattern?
Well, even if it matches, you cannot see it, right?
Yeah, yes, sir.
So let's say whatever matches should not be an empty string. Okay, yeah, you are correct. Line 10 also matches technically, but what will you do with a match which is of length 0? So let's say it's not a match.
Okay.
You can neither see it nor do anything about this epsilon string. Okay. Let's say this is not a match. Okay.
Yes, sir.
Yeah. Okay. And there may be another small thing. Yeah. So you see that I have used certain things like this caret, dollar, minus, parentheses. Okay. In a pattern, these things have a special meaning each, right? But what happens if I really want to find a string containing, for example, this character or this character? Okay, so these are also valid characters, right? So what do you think you should do? So these are some special characters, but they are also characters in their own right. Okay. So you may want string containing this caret, containing this opening bracket, and so on. Okay. The idea is simple. You just quote them. Quote means basically use this backslash thing. So dot essentially matches a single character, whatever it is. But if I say backslash dot, then it will match the character dot, period. Okay. And you also escape the special meaning of this opening square bracket by just putting a backslash before it. Okay. And this, star, this. Okay. And there are two other things which we will not understand for the moment. Opening and closed parentheses may also need to be quoted this way because in some other contexts they have different meanings. Okay. And likewise, and how do you quote this backslash? Although it does not appear here, I think it should be double backslash. Okay. And the forward slash also you need to quote when we will study substitution of a pattern by another pattern. We will see that this is used. Okay. You will not understand some of these things right now unless you see the real life applications, programs that use this kind of regular expressions. You are now only viewing things. Okay.
Sir, are these just escape characters?
Yes. These are escape characters. Like in C, \n means new line, \t means tab. It's exactly the same thing. This backward slash is just meant for escaping the special meanings of those, that character which is immediately following. Okay. And what is important is that this minus need not be quoted, depending upon the context. Okay. The pattern matcher understands whether you are essentially meaning a literal minus or a range. Okay. So, for example, if I say A to Z any number of times, followed by the literal period dot character, not anything. Okay. It essentially matches the last word with the period in a sentence if the word consists of lowercase letters only. Okay. And if the last word contains characters other than lowercase letters, okay, no. This is not fully correct, this sentence. Then only the period is matched. No, it's not necessarily only the period is matched. If it contains anything other than lowercase characters like a capital letter or minus sign or something like that, after that until the last period. Okay, so this statement is wrong. Okay, but it's possible that only this dot matches. Okay, and the star is empty. That is also possible. Okay, and maybe there is a bigger example here. What does it say? Here, this minus essentially means it's a range. Okay, any sequence of lowercase letters, possibly empty. Here it is unambiguous. right? Here it cannot mean a range. So I do not need to quote it or escape the special meaning of it, because the context makes it clear. Okay. So it's a literal minus. This is followed by, inside this, A to Z, and once again it's a literal minus. It cannot mean a range here. Here this first minus stands for the range. This does not stand for a range. Okay, so minus need not be quoted. Followed any number of times, followed by any sequence of characters, dot star. This should be followed by a literal dot, a period. Okay. And you can see these are the matches. First of all, this pattern must contain at least one minus. Okay. So if you look at line number 7, this does not qualify for getting selected. Okay. But this line, because of this hyphen or dash, whatever you call. Okay. So I think we should stop here. Let me tell you one more thing we will not study. So these are called the basic regular expressions. Okay, these constructs. In order to make your life simpler, people also have devised a set of extended regular expressions, where instead of star you can say I want exactly 5 matches, or you can say something like exactly between 17 and 18 or 17 and 29 matches. Okay, so some such constructs are also part of what is called a set of extended regular expressions. We will not study these extended regular expressions in this course. Later in your professional life, if you ever have a need to learn what these extended regular expressions are, what are the constructs, you can anyway go ahead and read a variety of tutorials, books, and all that stuff available. Okay. So henceforth, I will only restrict our attention to this restricted set of basic regular expressions consisting of these constructs, whatever I talked about today. Yeah. Of course, it's already 4:35. I can see I should not proceed further. So next week is your exam week, so we will not have any class in the next week. So next week, I will start with the remaining text processing utilities, grep, sed, and awk. I will see how much we can proceed. And then after that, we will study shell programming. Okay, so let me stop here. Yeah.
So I have a question.
Yeah, tell.
Let's say in this pattern, I write A to Z star minus A hyphen M minus Z. So which one of these gets substituted?
I think the A dash M dash Z. I think A to M will be first interpreted. And this will be followed by either Z or the literal minus. Yeah.
And also like when we start writing the regular expression, the first backslash we write, if we just write a star after that, it will be matching only star characters, right?
Yes. The literal start character, not anything.
Okay. Okay. Thank you, sir.
Yeah. Any other question?
Then, sir, how to match backslash?
I think it's not written here, backslash.
Okay.
Escape.
So let's say I want to match any number of dot. like any number of period characters. So what I do is I'll obviously start with the backslash, then dot and then star.
Yes.
Won't that give me everything because it's dot star? The first slash is for
No, no.
replacing the colon.
It's interpreted from left to right.
Okay, so the first slash which replaces the colon is also interpreted.
Colon.
Yeah, the colon, like in the editor, we first type the slash and then the colon gets replaced and then we write the regular expression.
No,
right?
no, no. Colon is just a place where you should, I would say, enter some comments. Actually, you see, you can enter set comments here. No, not really, not really. Sorry. No, if you have it, if it is a BI editor, you can enter some set comments here. So this is where you can type many things, not only search.
Okay.
Okay. This is a place for entering comments, what you want to do. Anyway, forget about this less. This is just for visualization. We will do our private pattern matching using the syntaxes provided by SAID or AWK. Okay. And grep is another, I would say, visualization like this. Okay. With some options, we will see in the next class. Yeah, any other question for the moment? Okay, if not, let us stop today. It's already a huge day for you. Relax. Okay, bye.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.